Welcome back to physics, and today we're going to be working on the pendulum lab. So there's a couple of things that we need to do, and I'm going to start off by sharing my screen and take you over here to Canvas. All right, so where we want to be is head over to Pendulum Lab, and that will start you out. We talked about what a pendulum is made of: a fixed point, some sort of string, rod, arm, whatever that extends to a mass or a bob. And so I asked you to complete an assignment called Pendulum Exploration. So I'm going to go over there for one moment. And basically what this assignment does is it lets you tell me your understanding of a pendulum. You're going to do this in Google Slides. So you're going to write down a few facts about a pendulum, and then tell me, where do we find pendulums in nature? Where do we find pendulums in our body? When you're done with that one, go over to this slide over here. You're going to do edit and copy, and then go over to your physics notebook, figure out where you'd like that slide to be. And it should be pretty much right here in patterns and inquiry. And then you're just going to do edit and paste, and that will put that slide right in there. All right, so once you have that part of it done, okay, that's all finished, then you're going to go back and do a little bit different part of the assignment. We're going to go on to the actual pendulum simulation. So in here, you're going to do this as a simulation on the computer. And to do that, we use this PhET simulation. And so it looks like this. There is a fixed point, a way to measure angles, the bob, a timer. We want to make sure the ruler and the stopwatch are on, that these two are not checked, period timers not checked, and over on the other side, we want to make sure that those are at their default 0.7 for the length of the arm. The mass is 1 kilogram for the bob. Gravity is set up as Earth. All right, so what we want to think about is, as we pull the bob back, we're going to let it go. And as it goes back and forth, we're going to start our timer and measure how much time it takes to do a number of swings. Okay, that's basically what we're going to do in the simulation. So in order to do that, what we did today was we went over and we said, okay, first thing that we are going to do is we are going to make a wild guess as to what you're actually going to think how the time will be for the pendulum to swing one time at 60 degrees. So in other words, if I took the pendulum up here all the way to 60 degrees, how long would it take for the pendulum to swing all the way over and all the way back? Okay, and so that is the first thing for you to do. Now, in order for you to get there, let me turn this back here to our basic beginning screen. Let's see here, go back, and go back. All right, because I need to give you a way to get into here at our activity page. And what you're going to do to get to this activity page is you want to be in something called Student Desmos. That's what it's called. So I'm going to give you a code right here. It's going to come up big and bright. And there it is, Y4Z2JQ. So you go to student.desmos.com. You can pause the video for a second if you need to, and then it will ask you for the code. Go ahead and put the code in, and that will take care of it. All right. Once you're there, there's 6 slides for you to go through. We only did 3 of them today. The first one is that wild guess. So it asks you, How long will it take for the pendulum to swing back and forth from a 60-degree angle? Put in a number. Second is, if with the pendulum, I increase that angle from 5, 10, 15, 20, 30, 40, 50, 60 degrees, what will be the time for one swing? And so if you think it'll stay constant, I'll erase that. Or if you think, oh, it'll, because it's up higher, it'll swing faster maybe, or it takes more time. You put in whatever you think it is and describe why you drew the line that way. So if I drew it this way, I might say, well, as the angle increases, it has farther to go, so it's going to take more time. That might be one way. If I went this way, I might say, oh, well, the higher it is, the faster it's going to go, so the less time it's going to take. So you have to decide what you would like that to say. So fill that in. And last, you're going to do the simulation for 10, 20, 30, 40, 50 degrees. I want this to be done in a special way. What I want you to do is you're going to pull it up here, and I'm just going to do like 40 degrees right there. And I'm going to let it go. It is not going to slow down because we put friction to 0. And so I'm going to set my timer to 0, and I'm going to wait until this bob is right about at the top of its swing. And then I want it to go across once, twice, 3 times stop. I want it to go 3 complete swings. So let's see, if I go there, that's 1, 2, 3. All right, so I would write down 5.23 seconds. That would be my first data point. And then I would do that a couple more times and fill in my worksheet. When we get back on the next class period, we're going to take these numbers and we're going to put them into a master sheet and see what all of that data looks like. Okay, so the assignment basically is to get that simulation completed. So see you next class.